Hello, and welcome to week number 11, BC Calculus. Let's get going. This week, or last week, we talked about first derivative test, and what we find with the first derivative test is max mins, where a function is increasing and decreasing. This week, we're going to be talking about the second derivative test. Second derivative test gives us concavity, where a function is concave up, concave down, and it also gives us inflection points. All right, so let's take a look at a problem from last week. It says use the first derivative test to find the relative extreme of this function. Okay, so let's work this thing out. First thing I'm going to do is I'm going to take the derivative. Obviously, when we're using the first derivative test, we need to use the first derivative. So the first derivative of this function should be, if I bring the 3 down, it's going to be x squared plus x minus 12. And if I factor this thing, hopefully it does factor out nicely. Let's see here, it factors down to x plus 4, x minus 3. Now you don't have to factor it, I just do because when I'm using the first derivative test, remember, we only have to figure out where the function is positive, negative. We don't care about what the value is. But now the places that this thing is 0 is going to be negative 4 and 3. So I'm going to have to set up my interval here. So I go from negative infinity to negative 4. I go from negative 4 to 3. And I go from 3 to infinity. So those are my intervals. I just need to find out where they are going to be positive and negative. So I always just put my function back up on top here, and that's a 4. Sorry about that. So if I take a value here, let's take negative 10. So I put negative 10 in here. Negative 10 plus 4, that's negative. Negative 10 minus 3, that's negative. 2 negatives is positive. So I know my function is increasing here. Then I take a number in between negative 4 and 3. Well, 0 is a very good number to use. If I put 0 in here, 0 plus 4 is positive. 0 minus 3, that's negative. A positive times negative is negative. So I know my function is decreasing here. And if I put a value in here, let's take 10. 10 plus 4, that's positive. And 10 minus 3, that's positive. So positive times a positive is positive. So I know my function is increasing here. So this is what is called the first derivative table. And it tells me where a function is increasing and decreasing. It also tells me that at x equals negative 4, I do have a maximum value. I don't know what that maximum value is. I don't know what the y value is, but if I plug it back in, if I put negative 4 back into the original function, I will get the y value. And here I know it's decreasing, then it increases. So I know I have, at x equals 3, I know I have a minimum value. I don't know what the minimum value is, but I do know that there is a minimum value there. So if I was going to graph this out, and as I said, I don't know what the values are at negative 4 and 3, but I know at negative 4 and at 3, I have a max, so let's just put it up here. Min, let's put it down here. It's increasing until it gets here, then it decreases until it gets here, and then it increases afterwards. So I know my graph is going to look something like this. I don't know where the values are. I don't know where the max is. I don't know where the min is because I did not plug it back into my calculator. But that is what my graph is going to look like, something like that. So here is a little bit of a, this kind of shows you what happens to that graph. Okay. Here is another one. Let's see here. Who is here today? Caleb, how are you doing today? You probably don't have any. There's nobody here, so I didn't turn on my settings. All right, Caleb, how are you today? All right. Caleb, what I'd like you to do is I'd like you to do this problem here. It is finding the first derivative, using the first derivative test to find the values of the max and min. Where is it increasing? Where is it decreasing? All right. And I don't have a calculator today, so I'm going to go with your answers. You can work it out on the board, or you can just put your answers in the chat box. I have to go let my dog in because I just let him out, and now he's scratching at the door to come back in. So I'm going to give you a couple of minutes to work on this, and then we'll go through it, okay? All right, let's take a look at this problem. Now, the first thing, remember, when we're dealing with the first derivative test, we want to get the first derivative, set it equal to 0, find out our intervals. So in this problem, I've got 12x to the third minus 12x squared minus 72x. Now, I'm looking at this and it's like, okay, looks like I can factor out a 12x, which is going to make it really easy. If I factor out a 12x, I'm left with x squared minus x plus 6. Is that right? So now I have, I'm going to factor this down to 12x, x minus 3x plus 2. So I have intervals of 0, 3, and -2. So if I make my first derivative test table up, which I always do, now some kids kind of chuckle when I do this, but to me it helps. So I have from -infinity to -2, from -2 to 0, 0 to 3, and from 3 to infinity. So now I have, and these are usually when you get a problem like these on an AP test, they're usually not going to be calculator based, because if it's calculator based, you can just graph it out and you can figure out where it's increasing and decreasing just by looking at your calculator. So they want you to be able to do these types of problems, and it does, you know, when you're dealing with a problem like this, there's a lot of material in here. You have to know how to take the derivative, you have to know how to factor, set up your intervals. There's a lot of stuff here. So now I'm just going to put my table or my factored form up on top, because I'm going to use this to figure out if it's positive or negative. So I'm going to take a value inside this interval. I'm going to take -10. Okay? I don't know why I take -10. I take anything I want. 12 times -10 is negative. -10 minus 3, that's negative. -10 plus 2, that's negative. Negative times negative times negative is negative. I know this function is decreasing from -infinity to -2. Now, from -2 to 0, let's just take -1. So if I put -1 in here, 12 times -1, that's negative. -1 minus 3, that's negative. -1 plus 2, that's positive. Negative times positive is positive. It's increasing here. Then from 0 to 3, let's take +1. If I put 1 in here, that's positive. 1 minus 3, that's negative. 1 plus 2, that's positive. Positive times positive is negative. It's decreasing here. And then my last interval, let's take 10. Positive, 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 increasing. So I know my function is decreasing from -infinity to -2, increasing from -2 to 0, decreasing from -0 to 3, and increasing from 3 to infinity. And then I could figure out max and mins if I had to. Any questions on the first derivative test? All right, then let's go on to the second derivative test. Now, you're going to find that this week is pretty easy. I mean, this week is just concavity and points of inflection. When you test concavity, the graph of a twice differentiable function, y is equal to f of x, is concave up on any interval where y double prime is greater than 0, and down where y double prime is less than 0. So basically, we're going to make the same table up that we did before. The only problem is now we are going to do the second derivative instead of the first derivative. So for example, and concavity, if it's positive, it's concave up. Negative, it's concave down. Oh, point of inflection. Where concavity changes from positive to negative, and negative to positive, there is a point of inflection there. This is the type of problem I used to give my students when I used to teach face-to-face. I'd give them one of these every day for a whole week. And, you know, it gives you a function. I believe that function is y is equal to x to the fourth minus 2x squared. And I had them fill this whole thing in. What are the local max, local mins, intervals where it's increasing, decreasing? So that would be the first derivative test. And then where's the function concave up? concave down, inflection points, make a sketch of the function. Okay, so let's do it. Y prime, 4x to the third minus 4x. I'm going to factor out 4x. That leaves me with x squared minus 1. This factors to x minus 1, x plus 1. Okay, so now if I was going to do my first derivative test, I'd have, let's see here, 0, 1, and negative 1. So I've got negative infinity to negative 1, negative 1 to 0. Oh, you just spilled on your computer. Not good, Caleb. Negative 1 to 0, 0 to 1, and 1 to infinity. Okay, and then I could just take my values. Let's go negative 10. So that would be negative, 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 which is going to be negative. So I know it's decreasing. Negative 1/2. So that's going to be negative, negative, positive. So that's going to be positive. How about 1/2? Positive, negative, positive. So that's going to be negative. And this is going to be positive. So now I could find my values, so I know exact points, but I'm not going to go there. Second derivative test. That means I need the second derivative. Okay, so that's going to be 12x squared minus 4. I'm going to factor out a 4. So that gives me 3x squared minus 1. Oh boy, this is going to be a little bit harder to come up with my value. So I'm just going to, what is that going to be? 1/3, the square root of 1/3. So I'm going to end up with plus or minus the square root of 1/3. So if I make my table up, my second derivative table, I'm going to end up with negative infinity to negative the square root of 1/3. Then I'm going to have the square root of a negative square root of 1/3 to the square root of 1/3. That's my second interval. And my last interval is the square root of 1/3 to infinity. All right, now, I don't care if it's negative square root of 1/3. I don't have to take that number. I'll use negative 10 again. So if I use negative 10 in here, negative 10 squared is 10. 3 times that's definitely going to be positive. I'm going to take 0 here. So if I put 0 in here, 0 minus 1, that's negative 1 times 4. That's a negative, and this is going to be positive. So I know it's going to be concave up, concave down, concave up. Where are the points of inflection? Well, points of inflection are at negative square root of 1/3 and positive square root of 1/3. Why is it there? Because it's changing from positive to negative or negative to positive. So this is the first and second derivative test. First derivative test gives us where it's increasing, decreasing. Second derivative test gives us where it's concave up, concave down, and points of inflection. Henry, any questions on that? All right. So I think I probably have a couple more examples in here. This is a pretty easy week this week. This is a pretty tough problem. It says the graph of y is equal to 3x to the fifth minus 10x to the fourth has an inflection point at. All right. So Henry, I'd like you to work this out and see what you get for an answer, okay? Since we do have quite a bit of time still, we'll let you guys let you do a little bit of work and see what you get for an answer there. All right, Henry, did you find an answer for this one yet? Now, this one's a little bit tricky. You think it's C. All right, let's try it. So the first thing I'm going to do is I'm going to take the first derivative. So that gives me 15x to the fourth minus 40x to the third. I don't care about this. I need the second derivative. So that's going to be 60x to the third minus 120x squared. So now I'm going to factor out a 60x squared. So that gives me x minus 2. So that means I know I have an inflection point at 0. Now I do not know I have an inflection point at 0. I take that back. I know that I have to check that interval out. All right, so I'm going to make my interval. This is second derivative test. So I've got negative infinity to 0, 0 to 2, 2 to infinity. All right, so now I'm going to plug a value in. I'm going to take, let's take negative 10. So if I put negative 10 in here, negative 10 squared is 10. 10 times 60 is 600. So this is definitely positive here. But if I put 10 in here, 10 minus 2, that's positive. So I know that this is positive. So now let's take positive 1 and put it in here. So that's positive. That's negative. So that's negative. So now let's put in 10. So if I put in 10 here, again, this isn't the one I thought it was, unless I made a mistake here. So that's 40x to the third. So 120x squared. 15x to the fourth. I thought this one didn't change concavity. Bummer. I guess it does. So now it changes at 0 and 2 because it's changing concavity or inflection points. Darn it, I thought this one, there was only one point of inflection here. No, I'm almost positive the answer is C. What? Did I do something wrong here? I've done this problem so many times. That's why I'm almost positive the answer is E. So let's try this again. It's really freaking me out here because I thought okay. So I'm gonna erase this because a lot of times when I do the problem and I do it just looking at the other doesn't seem right. All right. So if I take the first derivative, I've got what 15. Oops. Better make my pencil work. I've got 15x to the fourth minus 40x to the third. And if I do this again, 15 times 4, that's 60. X to the third minus 120x squared. So I'm going to pull out a 60x squared, which leaves me with x minus 2. Thought that's what we had before. So 0 and 2 are my values. So negative infinity to 0, 0 to 2, and 2 to infinity. All right, so if I put a value in here, negative, let's say negative 10. Negative 10 squared is positive, so that's positive. And that is going to be negative, that's going to be negative. So that is definitely negative. If I put positive 1 in here, oh, that's where my mistake was. If I put positive 1 in here, this is positive, and this is negative, because 1 minus 2 is negative. This is still negative, okay? So I go negative, negative, and then if I put a positive 10 in here, this is going to be positive. So it doesn't change signs here. It's concave down, it's concave down. Now it's concave up. There is only a point of inflection where it changes signs. So if it goes from a minus to a plus, that's changing signs. There is a point of inflection here at x equals 2. That is the only place there is a point of inflection because it only changes one time. Whew, I thought, man, I'm sorry about that. I don't know why I had my table wrong, but that is true. I mean, I've done this problem so many times in my career that I knew the answer because I know everybody goes for A because as soon as they find the two values, the 0 and the 2, they always go for A for an answer, and it's like, no, you've got to check to make sure that it changes from positive negative or negative positive, or else it's not a point of inflection. All right. Determine the intervals over which f of x equals x to the fourth to the third is concave down. All right. Now, if I was going to do this problem, this a problem that I'm going to have to use the chain rule, so I'm going to bring the 3 down, leave the middle alone, times the derivative of the middle, which is just 1. So this is my first derivative. Second derivative, well, bring the 2 down, so that gives me 6. Leave the middle alone, take the derivative of the middle, is just 1. So this is my second derivative. So my interval on this one is going to be negative infinity to 4 and 4 to infinity. Now, the only thing I need to know is where's it concave down. So all I have to do is look here. If I put, let's put 0 in here. If I put 0 in here, I've got 6 times negative 4, that's negative. Concave down between negative infinity and 4. So you really have to be good at taking derivatives. There's no question about it. Because in order to do the second derivative test, you have to be able to find the second derivative. This is the last slide for today. Henry, I want you to work this out and see what you get for an answer, okay? So Caleb, is your computer okay? That's a good thing. All right, Caleb, this is the last problem that we're working on today. We're trying to find the inflection points of this problem. So I'm giving you guys some time to work on that and see if you can find the inflection points. Henry says A. All right. Well, in order to find inflection points, remember we have to find out where the function, the second derivative. So my first derivative is 3x squared minus 6. Second derivative is 6x. That's a pretty easy one because there's only one value there. So I know that it's going to be from negative infinity to 0 and 0 to infinity. Whoa, how did they get ones in there? Did I do something wrong with my derivative here? Unless you guys both agreed to letter A. I'm looking at the, how did they get negative 6? You think the ones are just bogus? yeah, they don't make much sense, do they? Find the inflection point. Oh, I get it, because when you put the value back in, that gives you your point of, all right, I got it. Okay. I'm thinking of these as intervals when they're just the value. So 0 is going to be where the inflection point is. So if I put 0 back in here, that's negative 1. So 0, negative. Okay, I got it. I was looking at these as intervals, but it's a point where the point of inflection is. Okay, Got it. So letter A is correct. Whew. I thought I was doing something wrong there. All right, that is it for today. As I said, it's a very easy week. We're dealing with second derivative test, which gives us concavity, and it also gives us points of inflection. Any questions on any of this stuff? Not a problem, Caleb. Shouldn't be drinking hot chocolate next to your computer. All right. You guys have a good day. Bye.